In this session, we'll explore the nature of light and how it can be described in various ways. Light as a particle, light as a wave, light as a particle and wave, light as an electromagnetic radiation, light as a quantum field. Light as a particle. One way to think about light is as a stream of tiny particles called photons. Photons are the smallest units of light and they have no mass or charge. Photons are emitted or absorbed by atoms when they change their energy levels. For example, when an electron jumps from a higher to the lower orbit around the nucleus of an atom, it releases a photon with the specific energy and wavelength. This is how atoms produce light. Light as a wave. Yet another way to think about light is a form of energy that travels in wave. It consists of photons that travel in a wave-like pattern. Light travels in waves that have different wavelengths and frequencies, which determine its color and intensity. The wave nature of light explains many phenomena that cannot be explained by the particle nature alone. For example, the wave nature of light explains why we see rainbows, why we see colors, why we see interference preferences, and why we see polarization. Light as particle and wave. Light is unique in that it behaves like both particle and a wave. Light has properties of both a particle and an electromagnetic wave, but not all the properties of either. It consists of photons that travel in a wave-like pattern. This is known as the wave-particle duality of light. Light as electromagnetic radiation. Another way to think about light is as a form of electromagnetic radiation. Electromagnetic radiation is a type of energy that is produced by the movement of electric charges. It consists of electric and magnetic fields that oscillate perpendicular to each other and to the direction of propagation. Quantum field theory treats light not as a particle or a wave, but a quantum field. A quantum field can be thought of as a collection of vibrations and ripples that spread through space and time. Each vibration of a ripple corresponds to a particle or a photon. The energy and momentum of the photon depend on the frequency and wavelength of the vibration or ripple. The quantum field can also interact with other fields such as the electron field or the quark field, which describe matter. These interactions can create, destroy particles and change their properties. And to sum up, these are some of the generally accepted perspectives on nature of light. The true nature of light has characteristics as explained by above viewpoints and may have more possible perspectives that we are not aware of.